the instruction. What is an instruction? First we'll see what is a program. Generally, what is a program? You already know that a program contains set of instructions. For what these instructions? What these instructions will tell the computer? These instructions will tell what are the operations to be done, and to do those operations, what are the operands required, and in which sequence the instructions of a program are to be executed to get the desired output. This is what a program means. See the definition. The program is set of instructions. The program is set of instruction. What these instructions will specify? These will specify the operations. Operations means it can be an add operation, multiplication, subtraction, increment, anything. What is the operations to be done, and the operands. What is an operand? Operand is a data required. If you want to perform an add operation, what is required? You require the data. So the operands are also specified in the program. These operands can be a register operand or a memory operand. That means the data may be from registers, or you may retrieve the data from the memory. That is what register operand and memory operand. Okay. And the sequence. This program also specifies the sequence. That means it contains set of instructions, right? The program is having set of instruction in which sequence the instructions are to be executed to get the required output. All those are defined in a program. So it is a set of instructions which defines operations, operands, and the sequence of instructions to be executed to get the required output. Now we'll see what is an instruction. Instruction means it is a binary code which specifies, instruction is a binary code which specifies the sequence of micro operations to be done in the computer. Right? So what are to perform that instructions, what are the micro operations to be executed, all those will be defined in the instruction. Right? Let us suppose if you are reading any data from the main memory, right? To perform an addition operation, what you will do? You will fetch or you will retrieve the data from the main memory. You will store it in a register, and then only you will perform the addition operation. Once the operation is done, you will again store the result back in the main memory. All these micro operations were defined in a instruction. That means fetching the data, performing the addition, again storing the result back in the memory or any register, all these were defined in a register instruction, right? So it is a binary code which specifies the sequence of these micro operations to be done, right? Now, whenever a computer reads any instruction from the main memory, whenever an instruction is read from the memory, it will be placed in a control register. What this control will do? By seeing the binary code. We already told you that the instruction is a binary code. Whenever any instruction is read, this control will see the binary code of that instruction, and by seeing that binary code, it will identify what is to be done. Because for every instruction, a unique binary code will be given. By seeing that binary code, what is to be done, that will be decided by this control register, right? Let us see the instruction code. In an instruction, you will have an instruction code. Instruction is, it will specify all the micro operations to be done. Next, instruction code is, for every operation, the computer will give a binary. A group of bits were assigned for individual operations at the time of designing the computer. See, the instruction code is the group of bits. What this group of bits, what this instruction will do? It will tell the computer to perform a specific task, right? what the computer has to do, whether it has to perform addition operation, has to perform subtraction, or it has to perform an AND operation or anything. What is the specific operation to be done, that will be decided by seeing the code of this instruction later. And every computer will have its own format of the instruction. Let us see one example. If I have written an instruction like add 457, it is my instruction. What this instruction is telling? This instruction tells that you are supposed to perform addition operation. You are supposed to perform addition operation. To perform add operation, what is required? Obviously, you require the operands. That means you require the data. From where you have to get the data? You have to get the data from an address specified here. What is the address specified? 457 is the memory address. That means in the 457th location, whatever is present, retrieve that data and perform addition operation on the data. Perform addition operation on the data. This is what the meaning of this. So here add is an instruction code. Every operation is given with an instruction code at the time of designing your computer system, right? So in this instruction add is your operation code. Simply we'll call it as an opcode. It is a group of bit. This will specify what the computer has to do. Here user has written like add, but your computer does not understand this add, right? So for this add also you should specify one code in the form of zeros and ones, right? So like that, every operation is given with some group of bits that is known as an instruction code. By seeing that code, the computer will understand, yes, I have to perform an addition operation. I need to perform some transfer operation, or whatever the operation is to be performed, everything will be decided by the code. And this is known as, in simple term, we'll call it as an opcode or operation code. And what is this 457? This is the memory address. That means to perform this operation, you require the data, and where the data is present, it is present at location 457 in the memory. Clear? And you know that these operation codes, I already told you that these operation codes were fixed. They cannot be changed. For addition, for add operation, at the time of designing the computer, if a binary code something like 001 is given, the same code cannot be given for subtraction or any other operation. Those codes are fixed. For addition, if it is given as 001, that 001 cannot be given to any other one. They are fixed. Now, see how many bits you need to allocate for an operation code. What is an operation code or opcode? It is a group of bits. Some group of bits have to be allocated for every operation, right? How many bits you need to allocate? That is decided by the number of operations. That is decided based on the number of operation. Assume that if the number of operations were some 32, if 32 operations were there, to define a specific code for all those 32 operations, how many bits you need to allocate? 5 bits are to be allocated. Why? Because 2 power 5 is equivalent to 32. Clear? In the same way, if the number of operations were 16, how many bits you need to allocate? You need to allocate 4 bits for that opcode value, because 2 power 4 is 16. That is the reason. So, number of bits allocated for this operation code always depends on the number of operations available in the system. Now we'll see how these instructions, programs and opcodes, everything were organized in the system. How the memory components, instructions were organized in the system. In this, we are always considering a system, basic computer with a memory space of 4096 by 16 bits. In the first unit also I explained that we are considering a basic computer of size 4096 by 16 bits, which means that it contains 4096 words. The size word is 16 bits. The computer contains 4096 different words, 6 memory words. Now, this memory is mainly divided into two components. One is the instruction and the second one is the operands. It is divided into two components, instructions and operand. So, instruction. What is the size of instruction? The size of instruction is 16 bits because the size of your word is also 15. The size of instruction. You may have n number of instructions stored in this area. And in the same way, you may have n number of operands. That means n different data values may be stored here, right? How much space is given or what is the length of every instruction. The size of each instruction is to be of 16 bits. When you see the range is from 0 to 15. This is your instruction. And what is the size of operand? The same thing. Size of operand is also 16, right? Size of instruction and operand both are of size 16 bits. Now see the format of your instruction. And here along with these two we'll have one more component known as accumulator. It is also known as a processor register, right? So this will also store the data whenever you want to perform an addition operation. Here if the instruction is given like add 457, what I told you, you need to perform the addition operation with the data by considering the data present at this location. If I want to perform addition operation, how many are required? How many operands you require? Minimum of 2 operands you require, right? So from this location, how many you will get? You will get one data or one operand. So this operand has to be added to the data value present in the accumulator, right? So whatever the values are for any process to perform its execution, whatever is required will be storing in this accumulator. The intermediate result, whenever anything is retrieved from main memory, will store them into your accumulator, also known as a processor register, right? So just before that, we'll see what is an instruction format. So your instruction format is mainly divided into two components. One component is for address, second component is your operation code. One component address. How many bits are allocated for address? 12 bits are allocated for address. What is the total size of your instruction? 16 bits. In 16 bits, 12 bits are given for address. Now the question is, why only 12 bits are allocated for the address? Why not more than 12? Less than 12? Can anyone answer? Why only 12 bits are given for this address? What this address will specify? Here operation code is specified. We have here one operation code will be specified in this area. What is to be performed, that will be specified here. Suppose like addition, subtraction and so on. Whenever you want to perform any operation, you require some operands or you require some data. Where that data is present? Just by knowing this address value. So from where you have to retrieve the data to perform the corresponding operation, that address will be given by this address location. How many bits we have given? 12 bits were given. Any answer why we have given only 12 bits? If you know the answer, you can post it in the chat box. Why only 12 bits were given for address field? No? Now or else tell me, how many addresses were? Here I have considered my computer with a memory size of 4096 by 16 bits. That means what? How many words you can have? How many words were there? 4096 words are there. Each word is of size 16 bits, right? 4096 words. That means to retrieve each word or to identify or to locate each word, you require an address, right? That is in the same way, To locate all these 4096 locations, you require 4096 different address fields. 4096 address fields are required. That is the reason you have given 12 bits for your address field, since 2 power 12 is equivalent to 4096. Is it clear why we have given 12 bits for L address field? Because there present 4096 different locations. To locate each and every address uniquely, you require 12 bits, since 2 power 12 equal to 4096. Next, remaining bits were given for the operation code. Now, so this is your instruction format. Again, this operation code is again divided into two components. Your operation code is again divided into two components. First field will specifies the opcode, and one bit, the last MSB bit is known as ith bit. The last MSB bit is known as ith bit. What this ith bit will specify? This will specify the type of the address. Type of the address. So if this ith field value is 0, it specifies a direct address. If the value of ith field is 1, it specifies an indirect address. Clear? The address, these 16 bits are your instruction format. In these 16 bits, 12 bits are given for address field, and 3 bits are given for the operation code, and 1 bit is given for the type of the address, to know the type of the address. Now we'll see what is this address. Before that, let us see one example how then instruction will look like. Take the same instruction, add 457. Add 457. Well, this is your instruction, right? This is the instruction written by the user. Written by the user. But your computer does not contain the instruction like this. It does not it contains only zeros and ones. See what is the equivalent instruction format in binary. The equivalent instruction format for this is like this. So 16 bits. In these 16 bits, 457 is your address field, right? So how many bits you have to allocate? You need to allocate 12 bits from 0 to 11. From 0 to 11, you need to allocate for this address field. So from here, from this bit, this 11th bit to this 11th bit, the corresponding decimal value for this is 457. If you want, you can calculate. The corresponding value is 457. 1, 2, 3, 4. This value is 4. 0100 value is 4. 0101 is 5. 0111 is 7. So you got 457, right? Next, add. For I already told you that every computer will will generate a binary code for every opcode at the time of designing the system, and they will not be changed. They are fixed. So what is the code given for addition operation? How many bits were given for opcode? Only 12 bits. 3 bits. 12, 13, 14. What is the code for addition? 001 is the code for add operation. And what is the ith bit? What this MSB bit will specify? This will specify the type of the address. If it is 0, what does it mean? It means a direct address. If it is 1, it means an indirect address. Now we'll see what is a direct address and indirect address. So if the address is field, so first see direct address. So in your instruction format, if the address is field, that is your second part of your instruction. If this address is field, specifies the address of the operand. Specifies the address of the operand, then it is known as a direct address. If the same second field specifies address of the memory board where your actual operand is present. Where your actual operand is present. That is address of the address. Indirect address is something like address of the address. Then it indicates indirect address. Let us see one example. What is the instruction? My instruction is add 457. Right? So The instruction is located at location 22. My instruction is located at location or the address 22. What is the instruction given here? Here, this MSB bit specifies a type of the address as the value is 0. So, what does it mean? It is a direct address. It is a direct address, which means that whatever the address field you have here, this address field contains the actual or the required operand. So you can go to the location 457 and in this location you will have the your required operand. What is required to perform this addition operation? That data will be present here and you can directly retrieve the data. You can perform addition operation with the content present in the accumulator and you can store the result back in the accumulator. This is your direct address. Now see here, you have one more address at location 35. One more address is there at location 35 and in this address field my ith bit value is 1, which specifies this address is an indirect address. That means this specifies the address of the address. It is not your actual address. So go to your 300th location. Go to location 300. Here you will not have the operand value. This will contain, this location 300 contains where the actual value is present. That address will be given at here. What is this? So 1350. It will redirect to 1350th location. There you will have the actual operand. From here you can retrieve the data, perform whatever the operation is specified. If subtraction is specified here, then you can perform subtraction with this operand and the data present in the accumulator. You can store the result back in the accumulator. Clear? This is your ith bit, whether it is direct or and accumulator. We'll see one by one in detail. Along with all these register, you will have a memory of size what? 4096 by 16 bits. Now we'll see what are these registers. First register is your program counter. The size of your program counter is 12 bits. The size of program counter is 12 bits. What this program counter will store? Program counter will store the address of the next instruction to be executed. What is the next instruction to be executed? The address of that instruction will be stored in the program counter. Clear? Next one is the address register. It is again of size 12 bits from 0 to 11. Address register is also of size 12 bits. What will be stored here? This address register will hold the address for the memory. Address of the memory component is there in the address register. Therefore, using this address value, the control will point to that particular memory location to retrieve any required value. Next one is instruction register. We have seen what is this instruction register. We know that how it is of size 16 bits from 0 to 15. It will contain two parts. One is address part, opcode part. It again divided into two parts, ith field and opcode field. So this instruction register will hold the instruction code. The instruction register will hold the instruction code. And the next one is temporary register. It is again of size 16 bits. So while performing any micro operation, if there is any temporary data to be stored, those temporary values will be stored in the temporary register. During the execution of micro operations, if there are any temporary values to be stored, you can store in the temporary register. Next one is the data register. It is again of size 16 bits. So what will be there in the data register? This will hold the memory operand. That means whenever any data is retrieved from the main memory, whenever anything is retrieved from the main memory, that data will be stored in the data register. Right? The data will be stored in the data register. And the next one is the accumulator. I already told you. Accumulator is used for what? This accumulator will carry the results of the any micro operations. The result it will carry or it will store the results of the micro operations that are being executed, and it is again of size 16 bits. Next one is outer register, OUTR, outer register. The size of this is 8 bits from 0 to 7. This will hold the output character. Outer register holds the output character. That means what are the characters you want to display on the output device, those characters will be held in outer register. Whenever you want to place anything in the output device, those characters are present in the outer register. From here, they are redirected to your output device. And the last one is input register, INPR input register, which is again of size 8 bits. So this will hold the input character. That means characters coming from the input device. The data given by the input device were stored in the input register first. From the input device, whenever any data is coming, first it will be stored in the input register. Along with these register, you know that you will have a main memory. Without this, a computer will not work. And what is the size? This is 4096 by 16 size. Now, how to connect these registers? How to mutually connect these registers? You will need a common bus. You require a common bus to connect these registers as well as the memory. Right? So, your computer is having 8 registers and a memory unit. So, to have communication between the registers and the memory, there should be some information path. There should be some information path, and that information path is known as a common bus system. Right? This is your common bus system. So, you will have the memory and your registers, all the 8 registers, memory and all the 8 registers were present. Right? And each register along with the memory, each register and the memory are given with some signals. Next, the registers are your address register, program counter, data register, accumulator, and your temporary register. These are the 5 registers which are given with 3 signals. These 5 registers are given with 3 signals. Load signal, LD means load, INR means increment, CLR means clear. These are the 3 signals given for these 5 register. What this load signal will do? Load signal will allow the data to be loaded into a particular register. Let us suppose if the load signal of the register AR is high, then what does it mean? This address register can be loaded with an address value. If the load signal of this DR is high, then the data retrieved from the main memory can be loaded into your data register. In the same way, second signal is your increment signal. INR means increment signal. This increment will increase the content of that register by 1. Always increment means plus 1 only. So, the INR signal will increment the content of the register by 1. And the third signal is CLR. CLR signal means clear signal. This will clear the content of the register. Clearing means reset the register. Everything will be set to 0. Next, what are the leftover registers? IMPR register. Here, your IMPR register is not given with any signals. It doesn't require any signals. We'll call it as asynchronous because it does not depend on any signal. What is only required for IMPR? It only depends on the input device. Whatever is coming from the input device, that will be stored in the input register. So, it doesn't require any signals. Similarly, your instruction register as well as the outer register, these two are given only with the load signals. These two are only given with load signals. Why? Because when you see this outer register, it is given with only load signal. Why? Because whatever you want to display or whatever you want to give it to the output device, only that data will be present in the outer register, right? So whatever is to be transferred to the output device, you can transfer only through this register. At that time, the load signal of outer will be activated or it will become high. In the same way, instruction register, it is only loaded with the instruction, right? So these two requires only the load signal. Now all these registers are connected to a clock cycle. All the registers were connected to a clock cycle, and the output of the registers, output of all the registers as well as the memory is connected to your common bus, connected to a bus. Output of these registers and the memory are connected to a bus, and the data can be transferred like this. Therefore, you can say that the output of the registers as well as the memory can be transferred in the main memory. Then you can get some of these registers can also get the data from the register as an input. Register will send the data through the bus as an output. They also get the data from the bus as an input. Now when you see here, from memory unit you have a what we call output, and here from address register the output is redirected to, or output is given to the bus as well as to the memory component, because whichever here this address register contains what, the address of the memory component, right? So what that address will be provided, whenever this address is provided, into that address you can write something, or from that address you can read something, right? That is the reason the output of this address register is given as a input to this memory unit also. Similarly, the output is also given to your common bus system. Similarly, the output of PC is given DR, AC, IR, TR. And here the output of outer register is not given to the bus. Why? Because what is the output of outer register? Whatever you want to display it on the output device, those will be present in the outer register. You no need to send it through the common bus system, right? That is the reason you will not have any output from this outer register. In the same way, from this input register also you don't have any output line to the common bus, because input line is what, it will just take the input from the input device, but it will not give any output. It will just store whatever is coming from the input device. In the same way, outer, whatever you want to display on the output device, only those data will be placed in here. That is the reason you don't have any line from input register to the bus as well as from outer to the bus. And here everything is here. We have seen in the previous classes where bus is multiplexed. How you have constructed the bus we have seen, right? So using the multiplexers you have constructed the bus. Multiplexer means obviously it requires what? Obviously it requires selection lines as well as input line. Multiple input lines were given to the common bus system. And what are the inputs to the common bus system here? This is first input, second, third, fourth, fifth, sixth and seventh input. These are the inputs given to the common bus system. And whenever say these are the inputs, these many inputs were there, means how many selection lines should be there? There should be 3 selection lines. Why? Because which input line is to be selected? Which input line is to be selected, that will be decided by the selection line, right? So what is the maximum size of this register? Here the maximum size of the register is 16 bits. So maximum of 16 bits will come from this data register accumulator and so on. That is the reason here 16 bits can be transferred. Maximum of 16 bits can be transferred in this common bus system. So 16-bit bus will be there. So the data will be transferred from here to here. Now whenever you want to select this first line, you should have selection values as 0, 0, 1. Whenever you want to select the first line, 001 should be the light. Now, one more thing here. Here, when you see these input lines, memory is having an input line from the bus. All the register also having the inputs from the bus except accumulator. Except accumulator and INPR. These are the two register does not have any input from this common bus system. See here, ma. These are the input lines to the registers from this common bus, but accumulator and IMPR are not having any input line. Then how the accumulator will get the input? How the input register will get the input? Already know that input register INPR will get the input from the input device, right? Now, what is my question is how the accumulator will get the input? So, accumulator will get the input from adder and logic unit. Simply we'll call it as ALU. We'll have an ALU in your CPU, right? What this ALU will do? This is responsible to perform your arithmetic operations. ALU will do all the arithmetic operation. So, the output of ALU is given as input to the accumulator, right? Now the question is, from where this ALU is getting the input? ALU output you are giving it to accumulator. Output you are getting means it should be provided with some input. So your ALU is provided with 3 input lines. One input line is coming from the data register. The output of data register is given as one input to your ALU. Second input is coming from the INPR register, and the output of this accumulator is given as one more input line to the ALU. Right? So this will give an output which will be given as input to the accumulator. Along with this output, this ALU will also generate one extra bit. This E represents extra bit. When this extra bit will come? Any answer? I told you that this adder and logic circuit, this ALU is responsible for performing the arithmetic operation. Arithmetic operations are means what? Something like addition, subtraction and so on. Now, whenever you perform an arithmetic operation, add operation, binary addition or binary subtraction, along with the result, along with the sum or difference, you will get some more values. What are those? Suppose if you are performing binary addition on AI and BI, what you will get? You will get a sum of SI. Addition of A plus B, you will get one sum value. Along with the sum, sometimes you will get carry values. Carry values you will also get, right? So, those carry values will be stored in these extra bits. In the same way, when you are performing the subtraction operation, you require some borrow values. So, those borrow values are also stored in this extra bit. Similarly, when you are performing the multiplication operation, you may get an overflow. What is this overflow? I'll tell you in the next unit. You may get an overflow. Those overflow values will also be stored in this extra bit, right? But the remaining result, the output of this ILU will be given as input to your accumulator. This is the this is your common bus system. In this way, the registers and the memory unit can be communicated. Here, by using this communication, using this common bus system, you can transfer the data from one register to the another register or between registers and the memory components. Now, I'll give you one question. That is, my question is, I want to transfer the data. I want data from memory to the accumulator. Here, I want to transfer the data from this memory to the accumulator. Let us assume that, suppose if my question is, I want to transfer the data from this address register to AR to IR. My question is, I want to transfer data from AR to IR. How you will transfer? the output of AR will be there on this AR will give the output, right? So if you want to select this value, I want to transfer this content, that means I need to select this. So this is connected to which line? To the line 1. So if you want to select this line 1, what should be the selection values? 0, 0, 1. So select these S2, S1, S0 as 0, 0, 1. Then this 1 will be selected. So the value of AR will be placed in this common bus system and data will be transferred in the common bus system like this. Now my question is, one second. My question is, I want to transfer the data from AR to where? AR to IR. Here, this common bus system, from this common bus system, every register is getting the input. So if this outer requires the data, it will get the data. If TR requires the data from the common, whatever is transferred through the bus, it can take the data. Here, I want to transfer it to IR. So whatever is transferred in this bus system, that can be taken by this instruction register. Therefore, you can transfer the data from AR to IR. Right? In this way, you can transfer. But here, my question is, from memory unit, I want to transfer to the accumulator. How you can transfer? From memory unit, I want to transfer it to the accumulator. So you, in the same way, if you try to in the same way, if you try to transfer from memory unit to accumulator, how you will do? First, you will choose this line, this memory line, because memory line I want to transfer from here. So 7th line will be chosen. How you can choose the 7th line? By making the selection line values as ones, 1, 1, 1, which is equivalent to 7. So this 7 will be placed. The 7 will be selected. So this data will be placed in the common bus system and it is traveling like this. The data is traveling in the common bus system like this. Now I want to place it to where? I want to place it in the accumulator. But here, from this bus system, you don't have a input connection to the accumulator. Then how you can transfer the data? How you can transfer the data from memory to the accumulator? Will you try it and tell me in the next class? Or shall I complete? If you try it, then I'll start the quiz. Try it, ma. Try it and tell me the answer in the next class. Transfer the data from memory unit to the accumulator. Clear? Let me know whether what are the doubts you are having in the today's session. Tell me what are the topics you didn't understand. If you are having any doubts, you just post it in the chat box. Please post it in the chat box, ma. If you don't have any doubts, I'll start the quiz. In the next class, I'll explain instruction sets. What are different instruction formats you have, types of computer instructions, that we'll see in the next class. Mostly in the next 5-6 classes, I'll try to wind up this first unit. After that, we'll revise your first unit. From October 1st onwards, you are having your unit test 1. From 1st October to 7th October, you have first unit test. By that time, we'll finish our first unit, we'll revise first unit and we'll try to start the second unit also. No doubts? Shall I start the quiz? Shall I start the quiz? Okay, one second. Okay, ma. I am going to start the quiz. One second. Someone has asked me one doubt. Durga Prakash KMT. Carry and SEM. I didn't get this. Why only 12 bits given for address? What is this? Ma, I didn't get. Muriki Rohan KMIT, you asked something that carry 0 plus 0 and 1 plus 1. I didn't get this. What does it mean? Okay, you are trying to answer my question from outer to accumulator. Okay, you see, ma, how from outer to the accumulator you don't have any path, no? From this outer to the accumulator you don't have any path. Then how the data will be given or how the data will be transferred to accumulator? I understood that from memory the data is transferred in this common bus output register. This outer will take the data and this will give it to the accumulator. But from outer you don't have any communication link to the accumulator. So that is not the answer. Rohan KMIT. Outer to AC is not the answer. I didn't understand what this carry and sum. Durga Prakash KMIT. You said carry and sum, but I didn't understand. Okay. From DR. Yes, carry means extra bit, ma. When you see binary adder subtractor, there I explained the rules for binary addition and subtraction. When you perform addition, suppose if I perform 1 plus 1, then what is the result? The result is 0. The sum value is 0, but it will produce some carry value. That carry will be stored in the extra bit. Okay, from DR. You said that from DR. Yes, that is the correct answer, ma. From DR, you can send the data to what we call this accumulator. See here. So, I asked, the question is from memory to accumulator. So, what will happen? From memory, you will place by selecting the selection, by choosing the selection values as 1, 1, 1, the seventh line will be activated. This will be selected. So, memory unit will place the data in the common bus. Now, this data will be transferred like this. The data will be transferred like this. Now, here, this data register will choose this input. This data register will choose this input. So from here, this data register will choose the input by selecting this selection values as, 0, 1, 0, 0, 1, 1, then DR register will be selected. DR register will be selected. Then what happened whenever this DR register is selected? When this DR register is selected, what will happen? Whenever this data is coming here, by enabling this load signal, of this DR, whatever is coming from this memory unit, that you can place it here. Whatever coming from here, that you can place it here. Right? So, whenever you select this third line, by choosing the selection line values as 0, 1, 1, what will happen? This will be activated. This will be activated. When you see this, the output of DR is given to the common bus as well as it is given as one input to the adder logic unit. Right? So, whenever you choose this third line, by using the selection line values as 0, 1, 1, the data will be, the data from the data register is selected. Data from the data register is selected. So, you no need to place it in the bus. Anyway, the data can be placed in the bus, but you don't receive that data. You don't accept the data which is placed in the register. Whatever is coming from this data register, that you will be giving as an input to the adder logic unit. You know that when, by this adder logic unit will be giving you one output. That output you are giving as an input to the accumulator. Therefore, by enabling the load signal of your accumulator, the output of this adder will be given to the accumulator. What is the output of this ALU? The output of the ALU is equivalent to the DR register. Because from where you got here, from where you got the input, from DR you got the input. And DR data, what is the data loaded into the DR? When you have enabled this DR data, whenever the data is coming from this memory unit, this data is loaded into your data register. Therefore, whenever you want to transfer the data from memory to accumulator, direct transfer is not possible. First, you need to transfer from memory to the data register. From the data register, you can send it to the accumulator by enabling the load signals of DR as well as accumulator. Clear? So with this, I am going to end my today's session and we'll start the quizma. Thank you. From IR also, is it possible? From IR, it is not possible, ma. Why? Because from IR, you don't have a line. You don't have any connection to the accumulator. Who is that? Pranav Erram. You said that from IR also it is possible, but from IR it is not possible. Why? Because from IR you can place it in the bus, but when you want to transfer the data into the accumulator, that is not possible. And moreover, this IR holds what? This IR will hold the instruction. This will contain the address as well as the opcode as well as the ith bit. Whenever this data register will hold the data that is fetched from the memory unit, and there is no connection from IR to accumulator, so you cannot transfer using IR. Only way is intermediate or register used to transfer from memory to accumulator is DR, that is your data register. Clear? Thank you. Okay, ma, we'll start the quiz.